Then we would talk about the representation of the graph in the Java. How can we represent this data structure? So here, okay, we will talk about two methods. One is called adjacency matrix, another one is adjacency list. And you know that, as mentioned previously when talk about the list, okay, we can think of two ways to implement the list, right? One is to making use of a linked list, okay, or making use of an array to do so. Okay, first of all, for adjacency matrix, okay, we would just have an n times n matrix, and this matrix will contain only 1 or 0 in the entries. Okay, it means that Aij, okay, corresponding to the row and the column, is 1 if and only if I and j is an edge. Okay, what's that mean? Okay, for this graph, okay, you can see that for these 5 nodes, it has the following edges connecting the vertex. So it has 5 vertex, therefore the size will be 5 times 5. And the entry will be like this. Okay, 1 is connected to 2, so it contains a 1. 1 to 1, okay, you just ignore it and keep it 0. Okay, so 3, okay, no edge between 1 and 3, therefore it is 0. 1, 4 has an edge, so it is 1. Okay, so on and so forth. And as long as you can see that an edge is connecting 1 to 2, in other words, 2 is connected to 1, so it has another entry, okay, for 2, 1. Okay, so the rest of them will be put 1 by 1. So you can see that. So it formulates the matrix. So with the matrix here, then there are some property. For example, the diagonal entry must be 0, because, okay, as mentioned, the edge towards itself, okay, does not exist for this case. And another property is that if it is an undirected graph, so it must be symmetric and along this diagonal x-axis. So in other words, Aij is equal to Aji for all I and j. So that's the idea. Okay, so that is for the case of undirected graphs. So how about the directed graph? So the entry is not exactly the same. For example, you can see this case, 1 is connected to 4. Therefore, you can see this entry, 1 connected to 4. But there's no edge back from 4 to 1. Therefore, 4 to 1 is 0. So this is the property of the directed graph. Again, the diagonal entry is still 0. Okay, and the adjacency matrix of a digraph need not to be symmetric. So, and if you look at the matrix, okay, as mentioned, to implement it, okay, you would just need an n square piece of space. Okay, for an undirected graph, may store only lower or half or upper triangle, okay, except the diagonal. Okay, you can consider that, okay, the x-axis as a diagonal line, okay, which is actually the line of symmetry. and therefore it requires n minus 1 times n over 2 bits. And it takes big O n time to find the vertex degree. Okay, because it would go through all the entry or the vertex adjacent to a given vertex. Okay, just like you would like to know about the vertex, okay, about the connectivity, okay, you can just need to look at the entry of a row. So it would be big O n. Okay, so this is the idea of the adjacency matrix. Then let's